The diagram below shows ropes. F1 is equal to 450 newtons, F2 is equal to 300 newtons, and F3 is equal to 600 newtons hooked from the same point or from the same hook as they support the roof. So we have got these three forces, 1, 2, 3, and these forces are hooked from the same hook as they support the roof. Now, we have been given to say this is acting at 53 degrees from the positive x-axis, and this one is acting at 90 degrees, and this one is acting at 45 degrees from the negative x-axis. Now, we are going to resolve these into x and y components. So what we're going to do is, we're going to draw, we can resolve for each force. We have, let's say, solutions. So we have, for F1, we have this one, so we can resolve it into x and y. We have got this one. This is 45. This is, so let's begin by saying we have got this. So this is F1. This is 45. So this is it. Let's call this as Fx in the x component, as we have seen, and this one as Fy. So this one, we know from SOHCAHTOA that sine is equal to opposite over hypotenuse. So sine theta is equal to opposite, we have Fy, over, this is the, so this is F1y, okay, let's call this this, okay, over F1, so that Fy will be equal to F1 sine theta. So from this theta we have 45 degrees. If we plug it in and we plug the value of Fn1 or F1, we find the x, the y component. Then we know that cos is equal to adjacent over hypotenuse. So we have adjacent, which is this one, over this one. So we have cos theta is equal to adjacent F1x over F1. So F1x will give us F1. The values, we can plug in the values. Since the F1 we know that it is 450. So 450 newtons sine 45 degrees. Also here 450 newtons cos 45 degrees here. So what we're going to get here and here are the components of this force in x and y components respectively. So this is y, this is x. But when we come to the issue of quadrants, all angles in this one are positive. In this quadrant, sine is positive, but cos is negative. So this one is going to have a negative value. The x component of this force is going to have a negative value, because if this is the reference point, this is positive, this is negative. And angles in the second quadrant, the cosine of that angle in the second quadrant is a negative angle. Hence, this will bear a negative. So we can go on to find for F2. So F2 is acting at 90, this is 90 degrees. Okay, so measuring from this, we have for F2, let me advance this. X F2. So this one, it is acting at 90 degrees. And if we resolve this one, F2, we just have, so this one in X, since it is at 90, and as we saw in X, we are going to have F2X, we are going to have F2 cos theta, which will give us F2 cos 90 degrees. This will just give us a 0. Then F2y, we are going to have F2 sine theta. So for 90, this one, if we put in the value, F2, we have 300 newtons cos or sine. 300 newtons cos or sine 90 degrees. Here we are going to have 300 newtons. Sine 90 is equal to 1. 90 degrees is equal to 1. But cos 90 is equal to 0. So this is how we should go about to find the second part, since this is at 90 degrees. Let us go on and find the last one. Okay, we're going to resolve it right from here. So let us see if we resolve this. So we have F3x, F3y. So if this is the theta we have from so sine theta is equal to F3y over F3. So this one is going to give us F3 sine theta. So we're going to have 600 newtons sine 53 degrees. So this, when we evaluate this, that will be the y component of the third force. So for x, we have cos theta is equal to adjacent. So cos theta is equal to adjacent, which is F3 x over hypotenuse is F3. So F3x will be F3 cos theta. Plugging in the values, we have 600 newtons cos 53 degrees. What we are going to get is the value for the y component of the third force. So this is how you need to go about the forces when we are told to resolve into their respective components. Thank you so much for studying.